Hello everyone, this is James Shore with another test-driven JavaScript video. I'm recording this on December 16th, 2012, picking up right where we finished off in the last episode. And what we're working on here is getting the ability to track our mouse in our WeWikiPaint drawing code. So we have the ability right now, in the last episode, we got the ability to actually draw line segments in response to clicks. So that's fantastic. And this is actually test driven now. So what we have here is we have code that when we click the mouse, it will, this is our test code. We click the mouse and then we check that the line segments exist. So that's great. And here's the production code. It's fairly straightforward. So now what I'd like to do, when we left off, we were just getting the ability to do multiple line segments, which actually we already support. But I want to test it, and I particularly want to improve the way our test works. I want to make it easier to write our assertions. And this is an important part of test-driven development. As you work, you need to spend as much time on your tests as you do on your production code. You need to keep them clean and keep finding abstractions and factoring out common assertions and so forth. So what I'm going to do here is I'm going to write a little helper method that basically converts the paper, the paths in the paper, to, I think, a nested array. And that's what I've got sort of demonstrated here. Because I think that will be the easiest way to do it. So what I want to do is I want to say expect paper paths for paper to equal that array, 20, 30, blah, blah, blah. Now, I think what I'll do is I'll start with the code that I know works. So we're going to expect it to go from 20, 30 to 50, 60. And let's just change this back to, again, to what's working. So we should have passing tests right now. Except our lint failed for some reason. There. So it's complaining that paper path wasn't defined. Okay, so that works. Now what I want to do is replicate this code with a new function. I'm going to take this code here and move it down to here. And that was cut and paste instead of, or copy paste instead of cut and paste like I meant it to be. Okay, everything's still working. So now just write a little paper paths function. And maybe we call that paths in or something like that. And to start with, just going to have it basically do this. I'm going to have it figure out the relative position. And the relative position of what exactly? I guess path 4 is currently taking the bounding box and turning it into a string, but you know what? We don't need that complex of a path. Let's, so there's our bounding box. What if we just said box.x, box.y, box.x2, box.y2, and then return an array with start.x, end.x, start.y, end.x, end.y. Will that do the trick? I don't know. I feel like I kind of jumped through a lot there, so let's see if it works. Unnecessary semicolon on line 67. Unreachable far after return on line 63. Oh. and then element is not defined on line 60. Right, so what we need to do is get our elements. And our elements is our drawing elements. So element, our element is the first one of that. Okay. All right, that was a bit hacky, and it didn't work. So, but it's closer. I think what we need to do is just say box X. I don't think we need that relative position stuff at all. Okay. Expected 12, 22, 42, 52 to equal 20, 30, 50, 60. I'm not sure what's going on here. Oh. Okay. So this is saying that we expected 12, 22, 42, 52 to equal 20, 30, 50, 60, which means that what we're actually getting out of our click locations is, 12, etc., etc. That's because when we click, we are clicking at an exact page X and page Y. But what we're passing into our click mouse is not supposed to be a page X, page Y. It's supposed to be an offset. So what we need to do is actually add the relative position. And I think this was just there's something about the way we've changed this code. I think this problem actually existed before, and we resolved it by doing the relative position, but I think that was going in the wrong direction. We were subtracting the expected result. So yeah, actually we could say that we expect this to equal start X, start Y, end X, end Y. And I think that will work. Okay, it almost does. It says that it expects these to be equal and they look the same. The problem is we need to do something like a deep equal. I'm just not sure what the Jake expect.js equivalent of that is. So I'm going to go look that up and be back in a moment. Okay, I'm back. It looks like the appropriate incantation is EQL, which I can't say I love, but whatever. All right, so that works. So that's now basically saying what we were saying before, and you can see how it's definitely cleaned up this code. It's made it much nicer. I think we can make it nicer still. And the way I want to do that is by taking out this relative position stuff. Basically, rather than doing the relative position on what we expect it to equal, let's add the offset to the click event when we do fire the click event. So what we're doing here in relative position, I want to do in click mouse. Specifically, I want to say, let's add the top left of the drawing area to X and Y. And then what we'll do here is say X and Y. Now if I run that test, it should fail with expected 20, 30, 50, 60 to sort of equal 12, 22, 42, 52. And now we can say 12, 30, 50, 60. And the reason I like this is not only does it make the test smaller, but if we change something, let's say we click it 67, our error message is going to read really quickly, or read really clearly. It's going to say expected 20, 30, 50, 67 to equal 20, 30, 50, 60, which is what we're actually typing in here. So we don't have to do any calculations. So we can get rid of this relative stuff. We can put this back. And now we don't need to do the relative position here. And here, let's change these. Let's make this a relative x, relative y, and page x, page y. And we don't need this relative position code at all. There. That's getting cleaner. So let's go ahead and check that in. What we've done is we have simplified paper path assertions. And now what we want to do is have this actually return multiple arrays. Because what we're going to do is we're going to add this click mouse 40, 20, and we're going to want to say that it goes from 20, 30, 50, 60, and then another one from 50, 60 to 40, 20. So let's go ahead and add that. Easiest way to do that to start with is to just have this return multiple arrays. Of course, that won't fly long term. So now let's loop over the elements. And actually, you know what? I think we can map the elements. We'll map the elements so that each element has a box. And we return basically this. And we return that result. So this is a bit tricky. Well, before I explain it, let me make sure it works because it may not. No, oh, interesting. It does not work on IE8, presumably because IE8 doesn't have the map function. Okay, well, this would have been awesome if it had worked on IE8, but it doesn't. So what's happening here is map is a sort of functional programming tool. It's behind the scenes, it's looping over each element and creating a new array that has the values, this return value substitute for each element of the array. So it's just sort of a nice, concise way of doing things. We can't do that here, though. So what we're going to need to do is sort of an old-fashioned for loop where we're going to start out with a result, which is an empty array. Then we will take this code here and push that onto the result. And then we'll return the result. And hopefully that will work. It does. Great. Let's clean it up a little bit. And then in our last few moments before the end of the episode, we can do this additional click mouse, and hopefully, fingers crossed, hopefully that will work. But it doesn't. Expected 20, 30, 50, 60, 40, 20, 50, 60 to equal 20, 30, 50, 60. Oh, well, I think my expectation was wrong. No? Let's see. Expected 20, 30, 50, 60, 40, 20. Expected. Yeah. Our expectation is right. It's 50, 60, 40, 20, but we're getting 40, 20, 50, 60 at the end here. That is not right. So I'm not sure what's going on here, but that is all the time we have for this episode. So think about it, and when we pick up next time, we will solve that problem. Thanks for watching, everybody. I will catch you next time.